Okay, thanks everyone for coming. Let's get started. So I'm Andrew Hughes, Director of Slides. Director of Slides at Ping Identity. Dr. Torsten Lodderstedt from yes.com. We're here today to talk to you about digital credentials and standardization work in several standardization bodies for credential formats and issuance protocols, and this thing that some people call holder binding. So we'll take a look into the future a little bit. So what we're hoping to give you is a flavor of what goes on in standards bodies and how different outcomes trying to achieve the same goals can happen. And that's a good thing. Okay? So let's set the context a little bit. And if you're in the back, please come forward. It's okay if you leave early. So digital credentials in a nutshell. I'd like trying not to redefine things, but I like mixing up words. So over the last few years, I've tried to formulate a general statement about what is a digital credential. And so I've got a few statements that I think encapsulate a good sense of what these things are. So this is one of them. An issued digital credential conveys data that is an authentic representation of information held in a registry at the time of issuance. There are other kinds of digital credentials, but we tend to work on this kind of digital credential. The key thing is, it's data. The receiver knows that it's an authentic representation of what the issuer thought the data was when they issued it. So how do they get confidence that the data is an authentic representation at issuance? It's all the stuff around the data, the security features. On plastic cards, it's the holograms, that sort of thing. Digital, it's metadata, the packaging of the data, the signatures, the keys, and so on. And that's what gives confidence to the receiver of a credential that it's genuine and they can rely on it for certain properties. And of course, digital credentials come in many shapes, types, and formats, depending on the needs of the designers and definers of those types. So what's issuance protocols? So I tried to do a little bit with issuance protocols, describing what these things are. And you have to stay in more or less line of sight of the laptop with the button. Okay, so these statements assume a world where there are many, many wallets and many, many digital credential types, okay? And from many of the discussions at Identiverse and other conferences, this seems to be a prevailing thought, that we're not going to have a single wallet or 5 wallets. There'll be many kinds of wallets for different needs. And any of those digital wallets should be able to request, receive, validate, and store digital credentials that they encounter. Maybe not every single kind, but many of them. Okay? Over time, the numbers and variations and permutations may reduce, but in the world we're in for the next 10 years, it's going to be many and many. What that implies is that the means to obtain, install digital credentials must be standardized. Because if you're an issuer and you need to get a credential over to a wallet, you're not going to design an interface for every single wallet that you have never seen before on the internet. You need standardized interfaces, standardized protocols to convey those credentials over. And we call those means digital credential issuance protocols. It's an obvious statement, I know, but I'm a master of the obvious. Okay, so what drives the different designs that we see in the world? Well, requirements, of course. So credential issuers have an idea of what they want to issue. They have a usage scenario, many scenarios, many use cases. Some of the scenarios they need really, really strong protection of those critical credentials at all times, guaranteed, asserted, signed, sealed, delivered. Other uses are regular, everyday use. But the issuer knows what those scenarios are supposed to be, and they design and select appropriately. wallets are created by people, developers. And developers and designers have different abilities and capabilities and different market segments that they're trying to address. And so they make implementation choices. That's why we're going to have many wallets in the beginning, because everyone has a different idea of who's going to buy that widget. And they design according to the constraints appropriately. So issuing protocols have to accommodate and be that clutch between what credential issuers want to do with their credentials and what wallet providers are able to do with whatever they build. And that's what the issuance protocol does, in part. It says, here's the digital data with all the security features around it. Can I install it in that wallet? Yes, it's appropriate. Gets it over, wallet installs it. So that's what the issuance protocol is for. Impedance matching, I think, is one of the ways to describe it. Standard slide for any standards talk. Standardization reduces risk. So as an issuer, you want to have some level of certainty that there is a wallet out there, or many wallets out there, that you can issue your credentials into, and that people find delightful to use, and they can use that wallet to present credentials anywhere they need to, anywhere they wish to, within whatever constraints are appropriate for that wallet. And protocol standardization and standardized interfaces, they promise the goal of unlimited innovation for those issuers and developers of wallets. Okay? Without standards, you focus so much time on the custom integrations that you can't innovate. With standards, you have a hope of creating things that many will be able to use and consume. So what are we going to do this session? We're going to give you a little peek into some of the work we're doing across different standards bodies to define issuance protocols. There's lots of work going on. 2023-24 appears to be the year of issuance protocols, digital credential issuance protocols. Last year, the year before, was a lot about presentation protocols from the wallet to the verifier. The year before that, maybe, was the year of coming up with the data models and structures of credentials. And Torsten will talk about a survey of the field, some capabilities of those credential formats. And we're making progress. In the final part of the session, I'm going to talk about the arguments. So what are the unsettled topics within issuance protocols that different standards bodies are talking about in different ways, because we have different stakeholders, different requirements, and we're trying to solve for a specific solution case. So what are we arguing about? What are some of the differences between? And with that, I'll ask one more time, please consider moving closer to the front. We like to interact with our audiences. We're not offended if you leave early. Torsten, over to you.
Thank you very much. So hello from my side. I would like to add to what Andrew just said. You also need to consider the different cultures, the different standardization bodies to understand how they're going to work. So that's what I learned over the course of the last couple of years in that field. So I'm first talking about a community effort that we call the Credential Profile Comparison Matrix. It's a pretty complex name. But the idea is to provide the community with information and a tool to compare different technologies that exist in the market today for building credentials, digital credentials. And the work started spring 2020 at IW. And at that time, we in a German research project, were looking for the next step for us. So what's the technology we're going to use in the next stage of our project? And if those are new of you that are not familiar with IIW, it's an unconference, so you call a session and people come, or turn up, or they don't. And I just want to ask a very, very naive question. What's the best credential format? And we had a packed room with a lot of people that wanted to convince me that their credential format is the right one, right? And there was so much interest, and we did a follow-up session and gathered even more material, and we thought, well, that would be interesting material for the whole community. So we created a sheet and all that stuff. So yeah, and it went on and went on and went on. And we also wrote a paper around that describes how it works. We published that at Rebooting the Web of Trust. And there's also a presentation. You can take a look into that if you want. And yeah, the work will continue. So the slide is a bit out of date. So yesterday, Open Wallet Foundation's Technical Advisory Council approved the proposal to install a special interest group to give that work a home. So I'm really excited about that because that gives us more visibility and better support, and I hope also more contributors to that effort. What we wanted to achieve is really to allow for a fact-based comparison. There's a lot of emotion if people talk about their favorite tech stack, right? So formats and protocols and all that stuff, right? With blockchain, without blockchain, with DIDs, without DIDs. So we wanted to rationalize that discussion because we believe that having really a back-to-back comparison, for example, between AnonCreds on one hand and LD proofs on the other hand, will just help people that are really interested to implement products and projects. And so we try to facilitate an objective discussion, and I think we succeeded, kind of, at least for our project. So I'm speaking for about the ID Union project. It's a research project in Germany. So we use all that valuable information to decide about our future tech stack. And perhaps that's for you interesting as well. I will also share some of the insights and learnings that we deducted from that work. So what we do is we created this comparison matrix, and we started with a pretty simple sheet and just said, okay, this is AnonCreds, this and those capabilities, and this is W3C VCs, and it has that and that capabilities, and that, well, hold on a moment. There are a couple of different variants of W3C verifiable credentials, and even if you decide for one of those, how do you manage the key material for the issue? There are more than 100 DID methods out there, and you can even use other methods. So you can use different signature methods or signing algorithms, and you also want to maintain the status of your credential, and you can mix and match all those different components. And that's why we split the matrix in different categories. I'm going to show you the categories in a moment. So we split that material into different categories and then allow people to build their profiles on top of those categories. And then the sheet automatically calculates, all right, this profile, is it, for example, capable of selective disclosure? Has it unlinkability? Does it have hardware protection for the keys? Just to mention some of the criteria that we came up with. And a lot of experts from the different groups and the different camps contributed to the data. So we have the maintainer, but we are depending on the contributions of those that really implementing or specifying and implementing the different credential formats. Oh, that was too fast. So as I said, we started in spring IRW last year, then we set up that task force. It's really interesting. Germans only. We need more international contributions. Or perhaps we are the guys that do rational things. I don't know. I don't know.
Torsten, what language was the spreadsheet in? It was English, right?
Yes. And we have also, meanwhile, people from the Netherlands joining us. They joined us at Rebooting a Web of Trust. And as I said, a lot of people from the community, for example, Steve Kern, right, provided feedback. Those that are really working on the stuff. We wrote a paper at Rebooting a Web of Trust, and yeah, we also had follow-up sessions on subsequent IRWs. And yeah, as I said, the next step will be to move that into Open Wallet Foundation. And if you want to attend and to contribute, or just listen or observe, please go to the website of the Open Wallet Foundation. There should be, in the meantime, information about the special interest group. So, or if you are interested, and yeah, just talk to me or send me a message. So that's the metric. So you can scan the QR code to take a look into that. It's really huge. So I suggest you do that on a PC or on a notebook, because it's a lot of data. So it won't be fun on your smartphone. Just to give you an idea, those are the different categories that we have defined. So there is, and I'm starting from the second column, so it's credential format. So this is the actual representation that is used for the credential, such as it's JSON-based, it's CBOR-based, is it ASN1 or whatsoever. And then we've got the signing algorithms, we have the revocation algorithms, we have the key management methods, and we have trust management, right? So key allows you to distribute and resolve a key and then verify the authenticity and integrity of a credential. And the trust management elevates that on a new level, because then you can determine whether a certain issuer is trustworthy in a certain context, right? For example, if you want to know, is that issuer really a university that can issue a diploma, right? This is what trust management is all about. And you can see there are a lot of different criteria that we found out are interesting, ranging from implementation support through crypto agility, selective disclosure, which standardization body is the work done at IPR policy, and so on. This is all in the end interesting for people, because we came up with those criteria because people asked for those questions, right? Some insights. There are many credential formats. And the last time I counted, I think we had 15 in the matrix. And the number is not decreasing right now. And the number of profiles is, for obvious reasons, even higher by a magnitude, because you can combine a couple of things. And what that means is, if we want to achieve true interoperability, end-to-end interoperability in a whole ecosystem, you need to come down to one profile, at best with one format, one way to represent keys, one way to sign credentials, one way to manage the revocation status of those. This is really hard. I think we all can agree that's a cool idea. But if we would do a poll, I think, how many people in the room? I think that would be the number of profiles we would come up with. So there is some work underway, for example, in the European Union to really come down to a number of those profiles, because that's a prerequisite for true technical interoperability. And the metrics that allows to really have a rational comparison between the different credential formats, I think, is a good basis for that. This slide shows the candidates that we considered in our assessment for ID Union, for the ID Union project. And it also sheds some light to some of the criteria and how we assess the different credential formats regarding those criteria. So for us, selective disclosure is on the top of the list. So if you're doing verifiable credential, you want to just disclose the data that are used for the use case. So selective disclosure is of utmost importance. Unlinkability is also very important. So it means that if you present the credential twice, the relying party can, from the technical information, the credential not determine that's the same presenter and the same credential. And third, hardware security support is very important. Why is it important? This is nowadays the most effective mechanism to prevent someone from stealing your credentials and impersonating you as a user, right? So putting the keys that are used for the proof of possession when you present the credential, for example, in a TEE, in a secure enclave or strongbox, right now is the best mechanism. And that's why we really took a look into that. And we also looked into crypto agility, standardization, readiness, predicate support, and so on. Interestingly, if you take a look, you see that the unlinkability property and the hardware security property are mutually exclusive. And that to me was the most important learning from this metrics, right? So you need to decide whether you go, for example, with BBS or CL and get the unlinkability, or you get the prevention for replay and impersonation. Or you go for unlinkability and solve that problem otherwise, or vice versa. But you can't have everything in one bucket. And so we decided to go with a mechanism that gives us selective disclosure and hardware binding. Because we believe that if you have those as a fundamental underpinning, unlinkability, if it is needed, can be achieved using so-called ephemeral credentials. It's a bit weird, it's a workaround, but you can do it. What it means is the issuer just issues a batch of credentials with the same content, but different public keys, for example. And then the wallet uses those different copies to present the data to a verifier. So without going too much into details, the project decided to go forward with SDJOT VC. And if you have detailed questions on that, just talk to me. I will be around up until tomorrow. So just to get an overview of where we are right now, I have been talking about one of the three layers that are relevant for implementing a distributed or decentralized identity system, which was the credential layer. But there are two more layers that you need to really also take a look into to really define your technology stack for doing decentralized identity. The other one is the protocol layer, the credential exchange protocols, and the third layer is the key or trust layer. Some people call them VDR. Yeah? We have been looking into all those different layers, and the outcome of what we did influenced work that is now being done at OpenID Foundation, because as ID Union, we started to work on a complete interoperability profile, and that uses the technologies in the middle. And if you want to learn more about that, please come to the next session here in this room. In this session, we're going to take a deeper look into the protocol layer. So what are the protocols, or the most important protocols that exist right now in the market, and what are their properties? So, in my presentation, I will give you an overview on 4 of them. One is Didcom, or better, Didcom issue credential protocol. Then we've got OpenID for verifiable credential issuance. We've got ISO 23/2020-3.
It's burned in your brain now.
It's burned in my brain now, yeah, after I have to say that, I don't know, a couple of 100 times. And the VCAPI. So Didcom, in my perception, was the first protocol that was used in decentralized identity a couple of years back. And it's, in the end, it's first of all a generic communication protocol, right? Didcom is a message-based, end-to-end secure communication protocol, which uses key material represented or identified or referenced through DIDs on both ends of the communication channel. And I mention that because people typically mix up what Didcom is and what the protocols are built on top of Didcom. I typically compare Didcom to HTTPS from the abstraction layer, right? You can send messages through that secure channel. What you do is defined on the next layer. And that's the protocols that are built on top of Didcom. And what is relevant here is the Didcom issue credential protocol 3.0. And this protocol, for example, is format agnostic. And I believe that's a very important property because as we learned, there are so many credential formats. And if you, for example, want to build an application that uses a mobile driver's license and educational credentials, oh my God, you've got MDoc and JSON-LD involved in that thing. And if you don't want to implement different protocols for the different kind of credentials, a credential format agnostic protocol is a good idea. So Didcom is one of them. What is also very interesting, especially if you want to use different credential formats, Didcom issue credential also supports batch issuance, so you can ask for credentials in different formats and then store them in the protocol in the wallet. And depending on what the verifier wants to consume, the wallet then has different kinds of credential at its hand. A further property that is typically totally neglected, but to me is super important, is how the protocol facilitates user interaction. What the user UX looks like, and whether there are constraints on the UX. And with Didcom, for example, the idea is that all the communication goes through the wallet, meaning whatever the issuer wants to do or needs to do in order to authenticate the user, for example, to look the data up in the registry that Andrew mentioned, needs to go through that channel. And from personal experience, I know those communication protocols tend to be rather complex because the world of authentication is rather complex. It's no longer username password, right? It's two-factor authentication with different means and so on. So that's going to be pretty complex, and user consent is a whole new story. The specification is done at Decentralized Identity Foundation. Next contender is OpenID for Verifiable Credential Issuance. This protocol uses a pretty different philosophy from Didcom. Didcom is message-based. OpenID for Verifiable Credential Issuance is an API. So it's simpler. It's also limited in comparison to Didcom, but it's an API. And because it's an API, it can use and uses OAuth for the whole security stuff around it. Meaning, if a wallet wants to obtain a credential, it uses one of the OAuth grant types to get the user authenticated, to get a consent, and all that stuff. And then a access token is used to obtain the credential from the credential endpoint. And that's pretty much it is. Which means all the existing mechanisms that are in the market, grant types, security mechanisms, VCAPI, and so on, can all be leveraged. Or as one of my co-authors, Tobias Luker, typically puts that, we are standing on the shoulder of giants. So you might have deduced I'm one of the co-authors of that protocol. So I'm a bit biased, I admit. And what's really cool, if you're looking on how to build ecosystems, is you can turn an OpenID Connect OP rather quickly into a issuer of credentials. I believe that's very important because that's where the data is right now. There are systems in the world that already maintain digital identities. If we want to leverage them to build decentralized identity systems, that's a very important feature. And there is a project over at OpenID Foundation. It's GAIN. There's a community group doing experimentation and prototyping around how can we interconnect existing identity networks and ecosystems. And I'm one of the co-chairs of that group. And what we have done so far is we have interconnected OpenID Connect-based systems. And what we want to do in the next stage, we want to leverage the IDPs in that ecosystem to spit out credentials that can be consumed first by a wallet and then by a verifier. So that's one place where we are experimenting with that feature. And since I said user experience is important, there's a big difference between OpenID and Didcom. So the difference being that in OpenID, typically, if you use a code flow, for example, there's a redirect to the authorization server. Meaning, if the wallet wants to obtain a credential, the wallet doesn't need to know what user interface it needs to present in order to authenticate the user. That's left to the issuer. Screen control is moved to the issuer, and the issuer does whatever the issuer needs to do to authenticate the user, to onboard the user, to validate the user, whatsoever. That's super flexible. OpenID and Didcom share one property, and they are credential format agnostic in nature. All right, the specification is done at OpenID Foundation, and it is adopted by the European Union in the context of the updated eIDAS regulation for issuance, online presentation, and online authentication through the wallet. And we are really happy with that. All right, next contender, ISO 23220-3. At the end of the session, I'm going to ask you to state the name of that specification as well, right? Okay, so the ISO protocol shares one characteristic with Didcom. It's message-based. Yeah, it's message-based, and it's a protocol between what they call the MDoc app and the MDoc issuer. The difference to the previous protocols is that the ISO protocol is specific to one credential format. It's called MDoc. It's a binary format based on CBOR. It is designed for high assurance credentials and high secure issuance. And Andrew might comment on that as well. But in my perception, that's also the reason why there are different sub-protocols effectively to issue things, right? So in case of OpenID and Didcom, there's one protocol that is used for all the credential formats and the security levels. In ISO, it's different. And we've got the basic SA protocol, which in my perception is pretty much like OpenID. And we've got the HPKA SA protocol. And that's truly unique because it allows the issuer through the MDoc app to talk to a secure element. So all the communication is channeled through, which allows to issue stuff into a secure element residing in your phone. This is really the highest level of security you can achieve. And ISO also supports, as one option, OpenID for verifiable credential issuance. The specification, not a surprise, is done by ISO. And the ISO specification family, oh, that's a mistake. It's 18013-5. It's not 23/2020.
I might have edited the slide.
is cited in the EIDAS ARF for proximity presentation of stuff. And then we've got to the last contender, which is the VCAPI. The VCAPI is pretty different to the three other protocols. In a sense, it's in the end intended to be a RESTful API for the complete verifiable credential lifecycle, right? Creation, verification, deletion, and so on. And it also has issuance support. But it is mainly intended to be used internally within an issuer as an abstraction layer. And that's also the reason why VCAPI is typically combined with a different protocol if the issuer talks to a third party. And in a lot of cases, the wallet will be either a third party, or if it is a first party, it won't really do the authentication. So you have to combine it. One way is to combine it with OpenID for VCI. You can also use GmbH for that, for example. And what's also important to notice is that the VCAPI only supports JSON-LD-based credentials. So, which means, to summarize, we've got two contenders that are credential format agnostic. We've got two that are credential format specific. And there are a couple of also other properties. And I think what we're looking for is a real rational comparison of that stuff. And this work has started at last IAW. And right now, there's a group forming over a trust over IP that will be working on that stuff. So if you wanna contribute to this analysis as well, come talk to me. And with that, I would like to hand over to Andrew again.
Thank you, Torsten. ISO 23220, parts 1, 2, 3, 4, 5, 6, and 7. Okay. Thank you. That's a great overview. Important work to do the survey of the field, try to see what capabilities exist in different bodies for different reasons. Very good highlighting of the design philosophy going into different standards and protocols. We don't all come together as one big group of standards experts to come up with the single standard. If there ever becomes a single standard, it's 10, 20 years down the road. Okay? So, holder binding. For me, this is a fun topic because nobody agrees on what it should be. So, when we say holder binding in the context of digital credentials, everyone is forming a mental image of what that means, right? So let's start off with, who's the holder and what are they bound to? So the holder is actually a defined role in all of the credential standards that Torsten was talking about. It's any and all of these things. So it's the person, the device. It's a storage container, right? If the holder is the wallet, it's a storage container. Or is it the entity that possesses the keys or possesses the credentials? Maybe it's the actor with the authorization to receive, store, and present those credentials. That's a holder. Or is it the subject of the credential? Over time, in all the different standards for issuance and presentation, the holder has been one or more of these things, which makes it hard to pin down. It's getting better. Okay, so what's holder binding? This is a total paraphrasing of a lot of stuff. So it's basically the same questions. So is the presenter actually authorized to present that credential? Is the original recipient of that credential the subject of that credential, like it is in a driver's license, for example? Is the current holder of the credential the subject of that credential? If you hold your child's credential, are you the holder or are you something else? Does the subject control the keys and proofs for that credential? In other words, translated several times, it means can that subject prove that they are in control of that credential? Okay. The answer is yes. So some of the definitions. Okay. So in OpenID for verifiable credential issuance, holder binding is defined as proof of legitimate control of verifiable credential. I'm going to send in a pull request to it. It's just about possession in the text today. It says nothing about the presentation and ownership and authorization. So I'll send in a change request for that. In ISO 23220 Part 4, which is a presentation of mobile driver's licenses, we call it credential holder verification. It's about the 10th name we've come up with for this thing. And it's really about, is the presenter, can the verifier be sure that the entity presenting the MDoc or MDL is the holder, and the holder is the subject of the credential, right? So how does the verifier know that the credential is about the holder? And in the Verifiable Credentials Data Model, version 1.1, you actually have to specify it in a profile when you define it for a specific use case. But by default, the subject is the holder. There's a decision tree about subject and holder. It's in the spec, version 1.1. There's links in the PDF you can download. Okay, so holder, piece of cake. It's about 10 different things. Binding, what is binding? Binding in digital credentials describes relationships and also the means to prove or verify those relationships. It's many to many, it's one to one, it's one to many, it's many to one. It's any relationship between any of the things involved in the digital credential. Okay? So how are we going to manage all these relationships? And how are we going to manage all the proving and authentication involved with proving those relationships? I used to have the word, the title, a simple solution. Then someone suggests I take out the word simple. Let's go to tightly integrated federation. No, we're going decentralized. We're not going with a big monolithic system. That's the old way. So what's the nature of the problem we're trying to solve in all the standards bodies, in implementations as we see them? It's become clear that the semantics of those relationships between all the things, it's actually defined by the issuer of the credential. They decide what the use case is. They decide on what the scheme is. They decide on what the rules are for those credentials. And the verifier, because of the nature of the decentralization and the disconnection of the systems that we're designing today, the verifier can't always ask the issuer what they meant. If you're tightly integrated, you can ask the issuer because, well, you are the issuer, right? But in decentralized, you can't always ask what the semantics are. directly in a machine-readable way. So what are we going to do? Okay, there's only one way to define holder and subject across all standards everywhere. Well, maybe not. Okay, a trust framework for all trust frameworks, and define all the rules and all the legislation, all the no, let's not do that. One system, oh no, let's not do that. Okay, let's define a way of describing relationships and authentication and ensure that our protocols can convey the information. This is what we're doing. It might work. Well, we hope it will work. It's expressive. So some of the mechanisms for binding and proof of binding, private key possession, assumptions based on the text in a standard, like in mobile driver's license, it says the holder of a mobile driver's license is the subject of that mobile driver's license in the text of the standard. It's not in the protocol. But if you're using the ISO standards, you know the semantics of it because it says what it is. Presenting identification credentials, like two pieces of ID kind of idea, various ways of biometric matching. You could send the biometric template to the verifier for them to check, but that's not a great idea. And then on-device biometrics are other ways. These are just some of the samples that you could talk about. So in OpenID for verifiable credential issuance in the current draft, describes 3 kinds of binding for the holder. Remember, this is proof of possession. So there's cryptographic binding, claim-based binding. So you've got, this is the idea where we have another set of claims from an identification document that supports the credential that you are making claims about the holder about, and then biometrics matching as well between the credential and a biometric source. It's optional. You don't have to declare a binding for the holder. And there are 2 kinds of cryptographic binding options that are currently described. So the key material plus proof of control, or just the proof of control only. And the way you discover what the issuer meant is you ask their well-known endpoint for the parameters in the metadata. And in ISO, and if it wasn't clear from what Torsten was mentioning, I do most of my work in the ISO MDL and MDoc standard space. We're really wrestling with this concept of credential holder verification, where the verifier wants proof that the verifier wants proof that the holder is the presenter. So we're devising this way where an issuer can authorize mechanisms to basically authorize the verification means. Then the verifier can signal to the MDoc app, the MDL app, send me the proof that was authorized by the issuer. Some stuff happens. The verifier gets an attribute back saying, okay, we proved the binding. The credential holder is verified, authenticated. Here you go. So we're working out how that might work. And this is for the PDF download, which you can get on the app. Just links to some of the papers and other sources. If you want to take a picture of that, that's our last slide. Got 5 minutes of questions, if anyone has any questions. Hopefully this was a good overview of what's going on and how different approaches and different stakeholders and different communities come up with different requirements and solutions, and they evolve over time. So. Steve.
In your matrix that you developed for comparison, what do you use? What I'm really interested in is, for all these different features, what threats or risks do they mitigate? Like there was one, I think you brought up something, Torsten, about a hardware, a secure element, the communication directly to the secure element from MDL. What attacks is that trying to mitigate? To help judge the importance of that feature. That's an example.
You want to explain or show why?
Just rephrase it and then we'll take it. Okay, so the question is, what do some of the features mitigate? What threats do they mitigate? So the example you gave was the mobile driver's license one, where there's a mechanism for the issuer to talk directly to secure hardware. What if you don't trust the app so much? What if you don't trust passing keys through the app. One of the design philosophies that we have in the ISO work group is because we're considering the highest security, highest value credentials, we don't want to trust anything. We don't want to assume that the apps are implemented correctly in all ways. So we're leaving mechanisms to go directly to hardware so that we can just tunnel through whatever's there. We don't have to worry about rootkits so much and app security so much.
Yeah, I think my question was more of, is that an aspect of the spreadsheet at this point, those kinds of comparisons?
That would be, or would need to be included in the spreadsheet between the protocols.
Yeah.
I need to check. I mean, this work is pretty early, so I would like to take that as an impulse to check.
I don't think there's a threat analysis yet across all the protocol families, which I think that's the nature of the question.
No, I mean, you were asking whether this is a criteria in the sheet. That's how I read it. So we should go and check. And regarding the threat analysis, at least for OpenID, there is a complete threat analysis for the overall thing, which is important because you've got a couple of different protocols, but they are relying on each other. So the verifier might assume something that the issuer doesn't know, right? And the verification protocol might assume something that the issuance protocol cannot really fulfill. No one said it would be easy. Just it would be super privacy preserving and flexible and all that stuff. So, and we did that. So we have that security analysis, and there's also a scientific analysis going on right now to really make sure we have all the right measures in place for the threats there that we are aware of, right? That's always the general disclaimer on that, yeah.
Okay. And with that, we're at time. We'll hang around if you have other questions. Stay for the next talk. It is actually a very good one. Torsten will still be on stage.
Yeah, I will be on stage for the next talk, presenting together with Christina Yazuna OpenID for